Hi everyone, in this video let us understand how to upgrade the EKS managed node groups. MNG stands for managed node group. Okay, so typically the persona that we are dealing here is the DevOps or the platform engineers who will be doing something like CRUD operations, create the clusters, read, update and delete. Okay, in the update part we can have updating the control plane, data plane. That's where the managed node groups comes into picture. Then we can also keep the core components upgrade and any other third-party controllers that customers deploy in the cluster. Okay, let's get started. So there are two different types of upgrades when it comes to managed node groups. One is the config update. The config update typically includes any labels, tags that you're attaching to the node groups and the scaling configuration, maybe the min, max, desired capacity, all of that comes into the configuration aspect of the node groups. So this is nothing to do with the AMI or the OS image. It's just the configuration for the node group. Okay. And the second type of upgrade is a version upgrade. So this is where we will talk about the AMI upgrade. So here we will be upgrading the AMI to the current EKS or the Kubernetes version in which the cluster is currently configured at, right? So here we'll have two options. Customers can use EKS optimized AMI, that is the plain vanilla EKS AMIs which comes from AWS automatically on AL2, Amazon Linux 2023, or Bottle Rocket, Windows and things like that without any changes, right? So these are the off-the-shelf AMIs which comes from AWS. The second type of upgrade is basically custom AMI. Customers may build their own custom EKS AMIs based upon the security and compliance reasons. For example, they wanted to add hardening for CIS, STIG, or any other or custom hardening that they need to adhere to, right? So in the case of optimized AMI, you can use without launch template. LT stands for launch template, or you can use with LT also. So if you want to pass some configuration to the nodes, you can use launch template, or you just want to go with the default configuration, you can go with the LT as well. Okay, so in both options are available. And with custom AMI, it is recommended that you use a launch template because you're providing your own AMI, right? You're not using the EKS optimized AMI. So in that case, launch template is required. Now, in this case, we will be discussing only the first option, which is EKS optimized AMI without launch template for this demo. Okay. So we will take a simple use case where we use the off-the-shelf optimized AMI for Amazon Linux 2 and we'll update it without a launch template. Okay, so this is a scenario. So how does it work? Let us say we have our EKS clusters in AWS Cloud and the persona is DevOps or the platform engineers. Now you have your own cloud development environment, it's a Cloud9, where you have access to Terraform scripts. First, we will be deploying Cloudwatch event rule, which triggers a Lambda function periodically. It could be every day, midnight, or every once in a week. So we can decide the timings. Typically, it takes around 10 to 14 days, around 2 weeks of time to refresh. For the new release of the AMI. So the time may vary, but approximately 2 to 3 weeks is what typically you can see between the various versions of the AMI releases for a given Kubernetes version. So then you trigger a Lambda. The Lambda in turn will update the node groups. So Lambda first will check all the EKS clusters in that region for that account. And for a given EKS cluster, it will check a managed node group. And within the managed node group, it will check the current AMI version, the one which is currently configured for the managed node group. And it will make a call to the SSM parameter store to find out the latest AMI version which is available for the current Kubernetes version. So if there is a mismatch, that means if the latest version is different than what is already deployed, then it will do a version upgrade. Okay, so it's a simple logic. Look at the current release version of the AMI in the EKS cluster for the node group and then check the latest from the SSM parameter store. And if there is a mismatch, that means you do a upgrade. The same thing, it applies for all the managed node groups in the cluster. So this is what the Lambda does for every cluster in the particular region and in the account. Okay. So this is the layout of the demo. Now let's go to the code. So here, this is our instruction guide. First, we need to configure the list of clusters to update the MNG. Okay. So sometimes you do not want to, update each and every cluster. Some clusters may be production clusters. You do not want to disrupt them by any chance. So you can avoid them. So there is a configuration option available to configure which clusters you do not want to update. Okay. So let's say you do that. And how will you do that? You will do that as environment available to the Lambda. Okay, so this is the directory, and you can run the code um, standalone using the Python command directly, or you can deploy this in the in the Lambda console and run it through the Cloudwatch event on a regular basis. So now let us take a step back. Now let us go through the code and run the Lambda function manually, and then after that we will come back to the Terraform based deployment. That means we'll be running it through Lambda. Hi all, in this demo let us show how to update the managed node groups. Okay, so I took two clusters. One is the data on EKS Spark cluster, and the another one is EKS Blue reference Blue cluster. Okay, now here you see that there is a notification saying that the new AMI release available to update for the node group. So let's go further. So if you look at the version of the cluster is 1.29, and I will go to the compute section. Within that, you will see that there is one node group which is called platform secondary, and there is a update now option. So currently the AMI release version is this. So this is 1.29 and this is the date 2024 February 27. Okay, now if I click on update now, you will have multiple options. One is update node group version. So this is update your node group AMI version to the latest available version for your 1.29. Since the control plane is at 1.29 and the AMI will be updated to the latest AMI within the 1.29. Okay, it's the same Kubernetes 1.29 version. Within that, the latest AMI version, this will be updated. Okay, so that is the first option. The second option is change launch template version. So in case if you have provided any launch template while creating the manage node group, you can create a new version of the launch template and update that also. So for example, I can say enable this, and within that I can provide the launch template. And I did not provide any launch template, so no need to select this. So what is the required for launch template? So you need to provide some custom configuration to the EC2 machines that are getting added to the cluster. So any such custom configuration you can add to the launch template. But if you are referring to the managed node group and with the EKS optimized AMI, and you don't have any changes to the kubelet configuration or any such specific requirements, you don't need to provide any launch template. Okay, so you can just only update the node group version. Here there are two options: rolling update and the force update options. So in the case of rolling update, one node at a time will be drained and a new node will be created. The node will be cordoned. All the pods on that node will be evicted. So when you say evicting a pod, which means you're respecting the pod disruption budget also, PDB. Okay, so this is very smooth operation basically. So in case if you're not able to respect the PDB, then the update will fail. Okay, but there is a force update option also. If you select this, so if the pod disruption budget is not respected, it will forcefully, update the cluster anyway. So that means the node on which the pods are running will be restarted, and there may be a disruption to the workloads. So it's always better to configure the PDBs properly and spread the pods across the nodes so that you don't get into this challenge of the PDB not getting respected during the upgrade process. So for this demo purpose, I will select force update, and I can simply click update. So, but now I'm showing this as a part of the automation through the Lambda. Now I will not select this, I'll cancel for now. Okay, so this is one cluster. And one more thing to note is in the node group, if you go to the platform secondary, node group, you will see the launch template which is created. Okay, this is a launch template. So this is automatically created when you do EKS Kettle or any Terraform. So you can make any changes to the launch template, and this launch template will be used to create one more launch template for the auto scaling group, which is created as a part of the node group. Okay, we will discuss that later in a detailed video, but for now, assuming that we are not creating any specific launch template, this is a default one. Okay, now this is the cluster one. Now if you go to the cluster two, where you don't see any notification here, there is no notification about the node group change. Again, however, there is a notification with respect to the end of life support. So this is different, nothing to do with the upgrading of the managed node group. This is about the cluster version upgrade. We'll discuss that later. So if I go to the compute section and I see that there is one node group, and the latest AMI which is already available for this node group is this. So this particular node group is already at the latest version. We don't need to upgrade this node group. Whereas in the previous cluster, we see there is an update. Okay, so we can either manually update, but for this demo, we will be doing the automation. So we will be updating this via a Lambda function. Okay, let's go to the code. So this is our simple Lambda function. I'm writing this in Python, and I'm executing this function on a standalone terminal, but this will be run as a part of the cron job for periodic update. So I have provided some options to whitelist few clusters. You may not want to update each and every cluster because some clusters may be production and you don't want to update them at peak traffic time, right? So you can whitelist only those clusters which you wanted to upgrade. Okay. Now there is a small mapping table I've created. If this is the AMI type which is available in the node group, this is a corresponding SSM parameter I need to fetch for the latest AMI for that AMI type. Okay, this simple Lambda function. I'll check first of all the clusters, and for every cluster I check if the cluster is in the allowed whitelisted list. Then I list the node group for all the node groups in this cluster. For every node group, I'll kind of check. Okay, so first I will check the described node group, and from the managed node groups details, I'll check what is the AMI type and what is the corresponding release version currently. And then I will also get the latest AMI for that Kubernetes version. So I use this SM parameter. So I call sm.get parameter, provide this path based on the OS type. Is it Amazon Linux 2 or Amazon Linux 2023 or Bottle Rocket or Windows? So based on that, I'll provide a different path to this parameter, get parameter function. Then I'll get the latest AMI, and then I'll simply compare, right? If the release version of the latest AMI is greater than the current cluster version, then I'll call the update node group version function. Okay, so here I'm providing the cluster name, the node group name, and I'm not providing any release version. Though I know the AMI ID, but it's better to leave it because anyway by default it will take the latest AMI for the corresponding Kubernetes control plane version. Okay, and I'm doing the force update for the demo purpose. If you wanted to do a smooth upgrade, you can set it to false. Okay, so this is a very simple code, and I'll run this code on the terminal. So let us just run this. So if you look at the output of the code, first of all, there are two clusters that we are looking at. So it is checking for this cluster called data and EKS-Spark, and this is a node group. And I see that the latest AMI for this is March 15, but the current version for this is basically February 27. So that means we need to update. So the code is updating the manager node group now, and this is the response. So if I go to the console, let us check if there is a update triggered for this node group. I'll just refresh this page. So you see that it's updating now, right? So previously there is a update now option, but right now we don't see that it is updating now. So this is how we trigger the update through the code. Okay, so this may take a while because it is doing the rolling update and there are 5 nodes. So one at a time it has to drain and create new nodes. So we will go back to the code. And here for the second node group, which is a platform in the second cluster. So here we see that the latest version, the current version of the AMI is this and the latest version is this. So both of them are same. So there is no need to update. We saw that in the console also. So there's a message saying that the cluster is already at the latest AMI version. So it will skip the update. So this is how you can automate the manage node groups update processes through a cron job. Okay, and updation is very important for various reasons. Security is the most important reason that we need to keep refreshing the AMIs in a very smooth, full manner. And manage node groups handles that all of that overhead for customers so that you don't have to create that logic of trading the nodes, cordoning, and creating the new nodes. All of that is not required. It is completely inbuilt into the manage node group. So this is a best recommended option. Okay. So let me come back to the console and check what is the status of the node group update. It is still updating. I'll take a pause and wait for the updation to complete. Okay, so let's come back to the cluster again and see the status of the node group update. Now we see that now the manage node group platform secondary is now active and there is no update now option here. This is already at the latest version, so which means the update is working fine. So this is how you can do the automation for manage node groups in your cluster. Okay, this concludes the lab. So the second way of running this is through Lambda, like we discussed. Now let's go to the code, and this is our folder. And if you look at the code once, just to get an idea, the backend is where the Terraform state is configured. It is in S3 bucket at so and so path, and the lambda.tf is where we configure most of the code. So lambda function is created with Python 3.9 runtime. I gave a timeout of 10 minutes because sometimes it may take to go through the manage node groups. Lambda by default runs 3 seconds, which is not enough. So you need to provide a good enough amount of time, so 10 minutes in this case. Then this is the code folder where the actual Python code is residing. And this is the policy for the Lambda role, because Lambda needs a IAM role to access EKS clusters, access SM parameter, EC2 service for certain operations like description of the AMIs and things like that, right? So this is the role. Then here you can configure some clusters which you do not want to update, right, for various reasons. And this is the trigger, which is the Cloudwatch event. So every time the rule gets triggered, like for example, if you configure for every 1 day, right, it will be triggering in that periodicity, right? So this is a, let's go look at that in a minute, but for now look at the IAM role. For now this is where the policy document is configured. So in this case, I have EK star colon star all the operations. Similarly for IAM password also, I'm just configuring it. It may or may not be required, but I just configured it in this case. SM star and EC2 star, right? Because ideally we should use only the specific function that is required. But for this demo, I just used all the functions. The CloudWatch also, all the functions are included, all the APIs rather. Now in the CloudWatch rule, this is the cron job. That means every day at 12 o'clock midnight, the cron job will be triggering the Lambda. Okay, so it is enabled. So and this is simple configuration. Okay, now let's go through the code. The code we saw already in the previous demo. So this is the code. I'll go here for now in the interest of time. So let me do Terraform in it. So Terraform is completed. Terraform plan. TP stands for Terraform plan. I created alias in the batch profile. Terraform completed. Now I will apply with the TAA Terraform with auto approve. Terraform apply with auto approve. Yeah, it is completed. Now this is the Lambda function name and this is the Cloudwatch event rule name. Let's go to the console. This is our Lambda function which got created. So this is the code. So let me manually trigger this for now, because to trigger this it takes some time, because if you see the configuration, this is the environment configuration. It's a list of clusters which I do not want to trigger the Lambda code, and some general configuration will be around how much of memory required and what is the periodicity every 10 minutes. Now let me just go to the code and simply uh, do a test run just to see how it runs and see what would be the results for its simple test run. So this is the output of the Lambda function. So for example, let us take for one of the cluster, this cluster name so and so. This is the managed node group name. It's already the latest version. Okay. So for most of the clusters, it's already at the latest version. Node groups, the image is already updated in the previous runs. So that's why it has not triggered the update. But as we saw in the previous demo, in the standalone mode, we saw that the cluster, one of the cluster node group was upgraded. Okay, so this is how it looks like. So it basically prints what is the current, for example, let me take an example of this. So what is the current release version for the AMI, and this is the latest AMI ID for the Kubernetes version. This is the latest version, latest release version of that AMI, and you're just comparing these two and doing the trigger for the update, right? So this is how you can automate the managed node groups update on a periodic basis, and better to run this Lambda in a non-peak traffic hour, so that it is safer. Do not want to disturb any of the production workloads. Okay, so with this we conclude the demo.